Okay, so this problem is asking about a rocket ride at a carnival, which has 8 rocket-shaped cars hanging by chains from the outside edge of a large steel disc. Rotates about a vertical axis through the center of the ride, causing the cars to revolve in a circle. You estimate the disc is 5 meters in diameter, which is going to be 2.5 meters for the radius, and the chains are 6 meters long. The cars swing out into the chains are 20 degrees from vertical. What is the car's speed? So really early on in this problem, you are going to notice that the type of motion going on here is uniform circular motion, at least once it reaches that top speed, which is what we're going to be looking at, is when the rocket is at its top speed. And so knowing that, we know that we can use equations like mv squared over r to solve for the velocity of this rocket. But unfortunately, it's complicated by the fact that we don't have a mass. So we're going to deal with that later. But the first thing that can be really tricky to notice is that the path of this this rocket of this ride is not going to be have a radius of 2.5 meters of that disc. It's going to have a radius of that 2.5 meters plus some length, some additional radius that is there due to that the angle that the rocket is at provides. You can see the path of the rocket is actually going to be a good bit bigger than what it would be if it had the radius of that disc. So that's the first thing that we need to solve for before we can use any of our equations that relate to circular motion. So we were given that the chain length is 6 meters and that vertical angle is 20 degrees. So we can go ahead and just use trig and solve for that horizontal length to be 2.05 meters. That's going to be the additional amount of that radius. So we just add that to the 2.5 that we were initially given and come out as getting 4.55 meters for the radius of the path that the rocket is going to take. So the next thing that we're going to need to do is just keep on chugging along and solve for that car's speed. Since we don't know the mass, we can't actually use the mv squared over r yet. We also don't really know the force, the net force. So there's a few things that we are going to need to solve for before we can start plugging things in. So ideally we want an equation that's going to allow masses to cancel. And in this situation, I went ahead and drew a free body diagram of the rocket, which shows that the only net force that's acting on the rocket is going to be the x component of the tension, as the tension in the tension in the y direction and the force of gravity actually cancel, which makes sense considering the rocket on the ride, they're not moving up and down, they're staying in that x plane. So with that information, we know that tension in the y direction is equivalent to mg, and we still using that 20 degrees, we can use trig once again to solve for what that net force is going to be, that t sub x, just using trig. So that comes out as being mg tangent 20. And since this is circular motion, we also know that net force is mv squared over r. So we can set those two equal to each other. And luckily the mass does cancel here. And so all we need to do, since velocity is already a term in the equation for centripetal force, we can just rearrange the terms and plug in what we know, what we've already been given for the problem, and solve that the velocity of one of these rockets is going to be about 4.03 meters per second. So that is the answer to this problem. Thank you for listening.